So in this section, we turn away from simple interest and we start talking about something that's more commonly used with investments, and that's compound interest. So with simple interest, like we already looked at, interest is paid out on the principal and the principal alone. Any interest that is earned is deposited into a second account. But with compound interest, that interest is deposited into the same account, and as time goes on, the interest that you earn is paid on not only the principal, but the interest that you earned as well. So to illustrate that, we have Ewan and Rena getting a $1,000 prize in a writing contest. Ewan bought a $1,000 simple interest GIC, 5-year term, 3.6% paid annually. But Rena bought a 5-year compound interest GIC. Same 5-year term, same 3.6% interest, but this example is not only to get comfortable with the formula for compound interest, but also to illustrate the difference between simple and compound. So I'm going to leave the formula for now. I'm going to talk about Ewan. What we know is that his principal was $1,000. His term is 5 years. His interest rate, 0.036. And we want to know what he will have at the end of the investment. So with a simple interest formula, P plus PRT, will be a little bit squished. I apologize for that. So his A, his final amount, is $1,000 plus 1,000 times 0.036 times, I'll redo that, that is a 5 for his 5 years. Working that out, we get 1,000 plus 180, which gives him an amount at the end of this 5 years of $1,180. Flipping that to look at Rena, because she earned compound interest, we need to calculate this differently, and now I'll explain the compound interest formula down here. We have the same variables, A, P, R, T, but we also have N. Because with compound interest, the number of times per year that interest is compounded or paid does make a difference in the investment. So A is still the future value, P is still the principal, the 1 is in there as part of the calculation, R is the interest rate, N is the number of compounding periods per year, and T is the number of years. So looking at Rena back over here, her interest is again still 3.6% paid annually. Now we could have interest paid annually, which means it is paid once per year. Could have interest paid monthly, which would be 12 times per year. Weekly would be 52 times per year, and yes, I know there's not exactly 52 weeks in a year, but for the purposes of these calculations we're going to use 52. And the last other common one would be bi-weekly. This means every 2 weeks, so this would be 26 times per year. There are other compounding periods that do come up, quarterly, semi-monthly, but those are generally uncommon. These are the 4 most common ones. So I'm just going to flip the page to do Rena's calculation here. We still know her principal is still $1,000. Her term is still 5 years. Her interest rate still 0.3 0.036. But we also need to know n, the number of compounding periods, and because her interest is compounded annually, n will be 1. So it is a little bit more complex calculation because compound interest is a bit of a more complex concept. I'll just copy out the formula. Substitute in what we know. A we don't. P is 1,000. R is 0.036. N is 1. And in the exponent we have nt, which is n times t, so 1 times 5. There is no way to one-stop shop this type of question, so I will lay out every step we'll need to do. First is just some basic simplification. 0.036 divided by 1 is 0.036. And in the exponent, 1 times 5 is 5. Next step is to work out the bracket. 1 plus 0.036 is 1.036. Still to the power of 5. Go ahead and do 1.036 to the power of 5 in the calculator. It will be a long decimal. For now, we need to take every decimal place because we will be dealing with 2 decimal places in the final answer, and as yet we don't know where that's going to go. So take every decimal for now. That is 1.193435019. And it's okay if your calculator gives you more decimal places than that or less decimal places. Just take every one that you have. Last step, multiply that out. And I'm going to write this down with every decimal and then round it. You don't always have to. 1,193.435019. To round this off, since it's money, we'll be going to 2 decimal places, 1,193 and 44 cents. So you can see here there is a difference between Lena's 1,180 that she earned in simple interest versus Ewan's 1,193 and 44 cents that he earned with compound interest. Because as he earned interest, it might have been just a little bit at a time, but that little bit of interest earned its own interest, and it compounded and it built on each other, and it gave him an extra $13.44 here. The power of compound interest doesn't sit in short-term investments, and 5 years is kind of short. That's why there's only a small gain. Compound interest becomes much more visible with longer investments, 15 to 20 to 25 years and more. But it does make a difference.